Why would you create an abstraction? One reason is to simplify the underlying concept and API surface. Another reason, however, which I think is probably more common of an answer, is so that you can change the underlying implementation. While this can be true and it can work, it's not always as straightforward as you'd think. I'm going to give a couple examples of some nuanced things that you should be thinking about when you're designing an API. Hey everybody, it's Derek Martin from CodeOpinion.com. If you're new to my channel, I post videos on software architecture and design, so if you're into those topics, make sure to subscribe. This video is brought to you by EventStoreDB, the stream database built from the ground up for event sourcing, CQRS, and event-driven microservices. For more on EventStoreDB, check out the link in the description. So let's immediately jump into some code. Here I'm looking at Get My Orders Handler, which is for like an e-commerce, eShop on web sample application. And this particular request is to get your list of orders so you can list all your orders out. First thing that's happening here is we have this customer orders with specification where we pass in the username of who's logged in. And then we pass that specification to this order repository. So we have this iRead repository of T, which is the order entity. And that's what we're going to be getting out is this list of orders. So we get this collection of orders, and then we transform that into this order view model, and then we return it. Ultimately, that ends up in our view. So the first thing I want to talk about is expected behavior. And I'm going to use this iRead repository as the example. So iRead repository has this repository base. Here's the actual implementation that we were using behind the scenes with this EF repository, where it really is in, again, this base has all of it. But to kind of illustrate everything, I'm going to use the example of creating our own implementation that we could swap out with, which is usually, every time I hear this, it seems like everybody always mentions, oh, well, caching. That's an easy example of where you might swap this out, is so that you can cache the items in your repository. So here's the cache repository I'm creating. Here's all the methods that I have to implement. We have list, get by ID, get by spec, first or default, singular default, list, count, any, kind of the stereotypical things that you would probably think of when you're thinking about kind of a collection array-based list of items like an entity. So I've had one implementation here for list async. And because this is a cache, I'm using a memory cache, could be distributed cache like Redis, doesn't matter. But the point being is that we have this getter create async, specifying my cache key. And if we get a cache miss, here's what I'm doing. I'm actually just using the underlying entity framework repository that I was using kind of in the example, just to kind of pass things along so that it ultimately does get cached. So really, kind of like, what's the problem with this? This seems pretty straightforward. Seems like a valid use case. The issue here is expected behavior from the consumers that are using that iRead repository, that interface. If they previously had the expectation that they could read their own write, meaning that if you placed an order and then used the iRead repository that ultimately was using that new cache version, well, am I actually even going to get back my most recent order? Maybe not. And that's not what would be expected if we were previously using that other implementation. So expected behavior. Yes, we're conforming exactly to the interface. We're doing and returning everything it's expecting, but we're not doing so in the same way. The expectation is going to be different. We're not going to be fulfilling that exact same expectation. So that's a big key for me, and why I think that always that example of, oh yeah, just a repository and we can use the cache version. We can swap out that implementation. No, not really. As a consumer, I don't want to be very explicit if I'm willing to accept stale data, or potentially maybe we have an implementation that's using a read replica that's eventually consistent. If before I knew everything was consistent, and now behind the scenes it's not, I don't want to be very explicit about that. So to keep using the repository as an example in terms of creating different implementations, a lot of this is hinging on the idea that you're using something that's going to be collection-based for persistence. But what happens if you're not? So this idea that you can just change the implementation doesn't really hold up if you're not following the exact same kind of overall concepts of that. You could see earlier I was mentioning that we were using entity framework, but it could be any type of ORM or anything that really, it could be a document store, as long as we're thinking about the idea of kind of CRUD in nature of we can add items, we can list items, get a single item, the first item, kind of do a count or any, these types of operations. But is that always going to be the case in terms of persistence? Again, not really. So as the example, let's say we have a relational database or even a document store where we're recording current state. So we have a product in our warehouse, YYZ987, and we're recording current state. So we're recording the current quantity on hand, maybe the last time we received a product and the last time we shipped product. All this again is kind of using that iRepository with Entity Framework or whatever the case may be. But we decide, you know what? We actually don't want this implementation of how we're persisting state. We're going to move to event sourcing. And in event sourcing, rather what we'd be doing is we're going to be recording the stream of events that kind of are all the different state transitions that got us there. So instead of recording current state, we're saving and persisting things like these events of that we had product received, that we had another product received event, that we shipped some products, so we're reducing quantity, and that we did a product adjustment based on a stop count, that we also had to reduce our quantity. We ended up in the exact same place. We have all these different events that are occurring that can get us to current state, but this is a very different way of persisting state. What this means is when you're creating an abstraction, you're designing something, if you have an implementation in mind that you're aware of, you're likely going to create your abstraction based on that implementation. That's fine. That's not a bad thing. This can actually work out, but it doesn't mean that it's going to work all the time, that it's going to be so generic that it can handle every different use case like this. So to illustrate this more, what I'm going to do is first illustrate the idea if you were storing current state in an entity using something like Entity Framework. This is what this might look like. So whether you have things like the SKU, the quantity on hand, the shipped, received, everything that I was illustrating in kind of in that slide, and we have different methods for ship product that we're doing some check on the quantity, and then we're setting the state of what we want. Same thing for received product and adjust inventory. This is what you would typically think of when we're recording current state. However, if you're event sourcing, this is going to look very different. Is that I have the SKU, I have some internal state, which is really a projection, and the only thing I actually care about in our projection is anything we want to control invariance for, that we want to apply some type of business logic. So I'm loading all our events so that I can replay them to build out what our current state is, what that projection is. You'll notice here, I have the quantity on hand because that's the only thing we were actually caring about to do any logic off of. I'm not recording what the last shipped and last received is anywhere in here because it's irrelevant. I don't need it for anything. So I have our load, which is basically going to be loading all the products, replaying all the events. I have our methods, the same types of methods for ship and receive product, but rather I'm generating events and applying those events, which is doing those state changes for our projection. But again, that's not actually recorded anything. It's just done in memory each time we actually need to execute anything on our warehouse. So you can see that not only is the entity different, it's somewhat drastically different because we're more focusing now on events, and internally our state, we really just care about anything we need to apply invariance on. So what would a repository look like if we were event sourcing? Also different in terms of the functionality that we actually need. So here I have a get, kind of just get that single item. But what I'm doing is I'm using our event store to read all the events from the beginning. I'm replaying them to build current state, and then I'm returning that. Now, there is no idea of like adding or deleting necessarily a stream of events because it's not the same way. We're not really thinking of a collection of entities. Rather, we're thinking about streams of events. So I just have a save here, which is getting the events that haven't been committed yet to our stream of the state changes we made, and I'm persisting that to our event stream for that particular warehouse product. So fundamentally, the ideas here are very different. You wouldn't necessarily be using the same type of repository or interface for repository if you were using something like event sourcing or something more state-based that you potentially are using a relational database with. What this means is that if you're designing something like an interface, whether you have some type of implementation in mind or not, you're ultimately deciding what the model is and how you're going to support it. Not everything is going to fit that mold. Just like I was illustrating with recording current state and kind of collection-based and event sourcing and thinking about stream-based. And that's totally fine. But the idea that you're going to create some abstraction so that later on you can just change the underlying implementation detail and everything's going to be fine, no big deal, well, that's not really always the case. If you found this video helpful, please give it a thumbs up. If you want to chat with other software developers about these topics in software architecture and design, you can join my channel and get access to a private Discord server. The link's in the description on how to join. If you have any other thoughts or questions, make sure to leave a comment, and please subscribe for more videos on software architecture and design. Thanks.